So as I just said, the thing that is the toughest about today is identifying the u. All right, we're going to spend time specifically just identifying u. A reminder of things we're looking for with u. The highest power of x. Like if you have something that's x cubed and something else that's x squared, your u is going to be the x cubed part. Stuff inside of parentheses. Think about the baby with chain rule. Okay, the thing inside the parentheses, that's going to be important. If you have a natural log, it's probably the natural log. Or if you have e's, let's add some rules here. Let's write this one in. All right, this is on the second page, the back side. That's what I'm looking at right now. E's. If you have a problem like ex squared or e to the 3x, your u is going to be the exponent. X squared, 3x. If 2 e's, if you have 2 e's, pick the more complicated one. That won't make a ton of sense now, but remember that. That is kind of a trick. We will get better at this as we're going. We could use some common sense to figure this out. Sometimes some rules help us get common sense a little bit faster. All right, let's flip back over. We're looking at example 6 here. Let's see what we can do. So thinking about the rules we just said, we've got natural log to the 4th power of x all over x. The first thing we want to do is identify u. Thinking about the rules we just had, any guesses as to talk with your neighbor to say what you think natural log is, or what the u is going to be. Here's the key to this one. What's u going to be? It's not x. It's the natural log. If we see natural log, it's going to be natural log. And it's just natural log, not natural log of x to the 4th power. Think of the stuff in parentheses. If I were to rewrite this thing, it would be ln of x to the 4th. That's the same thing. It's the baby. It's the guy on the inside. All right? The more complicated thing, most of the time, is my u. If that's my u, we're going to find du dx. Derivative of natural log is going to be 1 over x. Solve for dx. Du dx, if I wanted to solve for dx, Dylan, what'd you do here to solve for dx? Multiply both sides by dx. That goes away. And then what? The x is on bottom, so how do I get rid of it? If it's being divided by x, what's the opposite of that? Multiply both sides by x. Multiply both sides by x. So x du is equal to dx. X du is equal to dx. It was 1 over x, so we multiplied it to get rid of it. Once we've done that, we're going to plug in. Are there any constants? Anything I can pull out? No constants. And so we're going to rewrite this thing. ln of x, I'm replacing ln of x. I'm replacing that with u, and it's still to the 4th power. All over, I'm not replacing that x on bottom, it's still x. And I'm going to multiply that whole thing by what dx is, which is x du. If we did it right, before we integrate, the x's will cancel. I cannot integrate u and x. Bless you. Is that going to happen here? It better. The x's better cancel, because if not, we screwed it up. So now I have this problem, u to the 4th du. That's a real simple integration. Don't get that confused with derivatives. You're doing antiderivatives. You're going backwards. Talk with your neighbor. Get an antiderivative of that thing. Show me with your fingers what's your exponent going to be on your u. On your x, what's the exponent going to be on u? It's 5. We're going back a step. Okay, don't get that confused with derivatives. It's weird because you're doing derivatives and integrals on the same problem. U to the 5th, and then we divide by our new exponent. So it's a 1/5 in front. We integrated du. There weren't any bounds. We need a plus c. Once we've done that, we can actually plug in what u was. U was natural log of x. That is my answer. You could write it like that. That's the same thing as this. Doesn't matter. Just be able to recognize the difference between the two. Or not the differences. Represent the same thing. Questions on 6? Let's go to 7. E to the x all over e to the x plus 1 to the 4th power. The toughest part is identifying u. Take a second with your neighbor. Identify u. Here we go. We're trying to identify it. Let's do our fun game again. I'm going to count to 3, and you're going to tell me what you think the u is going to be. Ready? 1, 2, 3. All right, good. We stopped at the right time. E to the x plus 1. There were 2 e's in this problem. So if there are 2 e's, we want to pick the more complicated one. Again, the whole concept with this is, think about in a second, we have to take the derivative. Taking the derivative of 1 goes away. That's a little bit more complicated, but it's going to be simple when we take the derivative. Otherwise, we won't be able to cancel that stuff. And so when we look at this thing, the derivative is the more complicated e. I'm glad nobody said with the 4th power, because we're talking about the baby, the thing inside the parentheses. E to the x plus 1. We're going to find du over dx. So, Nick, what's the derivative of e to the x plus 1 going to get me? E to the x. The derivative of e is what he sees. The derivative of 1 goes away. He wants to solve for dx. So he's multiplying both sides by dx. That cancels. He wants to get rid of the e to the x, so he's going to divide by it. Solve that problem the rest of the way. You now know what dx is. You now know what u is. Sub in and go. Here we go. We solved this thing. We've got this. We are substituting in. First thing I always look for is constants. Are there constants? No constants. So we're plugging in. We're integrating. We've got e to the x on top. We now got u to the 4th on bottom. Instead of dx, I'm going to plug in what dx is, which is that guy. Du over e to the x. If we did it right, the x's should cancel. I got an e to the x on top and e to the x on bottom. Yay for us. They cancel. And so I'm integrating u to the 4th. It's in the denominator, so I'm going to write that as u to the negative 4 du. Questions on that? I lost a couple people there. Yes, ma'am. It's going to be more beneficial to us because think about what our next step is. It's u to the negative 4th. We're going to add 1 to the exponent. And so if you think negative 4, then you'll add 1 and get negative 3 like you should. So we're adding 1 to our exponent. It's now u to the negative 3. We're going to divide by our new exponent, so it's divided by 1/3, negative, plus c. So my answer is going to be negative 1/3. E to the x plus 1, I plug back in my u. Negative 3 plus c. Obviously, it's the negative 3rd power. You could put it in your denominator as well. It would get you the same answer. It's just reps. There are places you will screw these up. They are complicated questions. But if you follow the processes and you think about it correctly, you'll be okay. Questions on 7. Let's go to 8. Let's do one more here together. Cosine. Cosine of the square root of x all over the square root of x. Talk with your neighbor. Decide what u is going to be. Here we go. Ready? You're going to tell me u. 1, 2, 3. Good. Square root of x. It's in the parentheses. That's the concept we're dealing with here. U is the square root of x. I'm going to write it as x to the 1/2 power. Solve this one. Be careful here. You're going to deal with negative exponents, and they're going to be on the bottom, and you're going to flip them to the top. Be careful. When you start to integrate, remember, everything's going to cancel. So you got to cancel out that square root of x on bottom eventually. Take a second with your neighbor and do that. The place we're getting stuck as I walk around is this part. The derivative of u, I subtract 1 from my exponent, so now it's negative 1/2. I multiply by the exponent and then subtract 1, so it's 1/2 x to the negative 1/2. That is the setup. You could then solve this guy a lot of different ways, but I want to get dx by itself. How to get dx by itself? Well, I'm going to multiply both sides by dx. Those are going to cancel. I've got du equals 1/2 x to the negative 1/2. I want to get rid of 1/2. How do I get rid of 1/2? I'm going to multiply by 2. And so when I multiply this side by 2, this side by 2, that's going to cancel. And then I want to get rid of x to the negative 1/2 power. It's being multiplied right now. So if I want to get rid of it being multiplied, what can I do with it? I'm going to divide. You might have done this differently. This is just how I'm writing it. I'm going to divide both sides by x to the negative 1/2 power. If x to the it's a negative exponent, it's in the denominator, what can I really rewrite that as? Positive, and where's it going to be? On top. It's got a negative exponent on bottom. That is the same thing as 2x to the 1/2 du is equal to dx. That is complicated. We just flipped back and forth like 6 times. All right, don't let that be overwhelming to you. That's algebra stuff. We're integrating cosine of u all over. I'm going to just write it as x to the 1/2 power since I've got the other one as x to the 1/2 power. And I'm going to replace dx with this guy, 2x to the 1/2 power du. Yes, sir. We don't want to. We don't want to. You could have, but the u we represented was the other one. If you're going to do that, when you plugged in, you would have to do it the same thing here. See how that's a u as well? Because it's x to the 1/2 power. I see where your thought is there. It's not a bad thought, but you would have to make sure you replaced all of them. Just don't do it. We replaced that one. The reason I don't need to replace the other one is because what's my next step going to be? Cancel. I've got an x to the 1/2 right there and x to the 1/2 right there. However you write it, you want those things to cancel. Because when I integrate this thing, I only want u's. I've got a constant. I only want to be with u's. Put a 2 right there. Now we're integrating cosine u du. Cosine u du. What is the antiderivative? You got cosine. You're doing the antiderivative cosine, so that's going to get me 2 sine plus c. We're going to rewrite what u is. U is x to the 1/2 power. Plus c. And you could do square root of x as well. Same difference. Questions with that? Again, the most challenging thing today was identifying u's. We're going to take a second. Let's just identify some u's. So I've got some worksheets here. I'm going to pull one up, and we are just going to find some u's and see what we think here. All right. So again, I could pass out whiteboards. I'm not passing out whiteboards. We are going to do the 1, 2, 3 countdown, and you're going to tell me what you think it is. Okay? All right, this is being weird. This first one right here, e to the 8x. Think about it for a second. I'm going to count you down, and we're going to say it in unison what you think it is. If you want to converse with your neighbor for 2 seconds, do it. All right, ready? 3, 2, 1. 8x. It's just e, and so the best thing to deal with is just the exponent. Okay? This screen isn't going to like me. I'm going to go back to my other worksheet. Oh, that one's not responding. Here we go. Looking at number 1. This one's a little bit tougher. I've got x over x squared plus 1. Think about it for a second. Talk with your neighbor if you need it. Count down from 3. 3, 2, 1. X squared plus 1. X squared plus 1. That whole denominator. All right, we want to deal with that whole thing. When you have like a plus, a constant, it's probably going to be part of your u because we don't want to deal with that very much here. That x squared plus 1, it's all going together because the derivative of x squared plus 1 is going to get me that x. What would the u be there? That whole bottom, 5 minus 3x. We did one similar to that the other day. Dx is on the top. It's just a constant. It's just times dx. Natural log of x all over x squared. 3, 2, 1. Just natural log of x, because when I take the derivative, it'll cancel with the other one. Think about it. 3, 2, 1. Cosine of t. Okay, I've got multiple things, but I've got 1e. Odds are you want to mess with the exponent. Cosine of t. Last one of this. Three, 2, 1. All right, so we had a battle. Some said square root of 1 plus e to the x. Some just said e to the x plus, or 1 plus e to the x. Why is it just 1 plus e to the x? Somebody, raise your hand. There you go, Nate. It's to the 1/2 power. Think of that's the baby. It's inside parentheses. All of that is to the 1/2 power. That's going to be my starting point. Questions with something we did today? Okay, again, I think, how much time we have? I'm 38. I still got 18 minutes. We're going to try one more here before we go. So tomorrow you're practicing this stuff. The answers are all on there. You're going to go through it. On Monday next week, sorry, I didn't mean to turn the page. On Monday next week, we are going to do these same problems with bounds. I'm going to introduce it real quick. Okay, we're not going super deep. We'll do one more of these together and we'll be done. Give me 3 more minutes. We are integrating this thing. Tangent of x, secant squared of x. I'm integrating it from 0 to pi over 4. So this guy's different because I've got 0 and pi over 4. This one's a little bit tougher. Identify u, and let me give you a hint here with u. Remember what you're going to do with u next. You're going to take the derivative. You're going to plug that derivative back in, and it's going to cancel with something else. So take a second with your neighbor. Think of what you think u should be. Here we go. We are finding u. Anybody confident in what they think u should be? Nolan, yeah, you had a good description. Tell me what you think u is going to be. U is tangent x. He's correct. U is going to be tangent x. Let's talk through it, and you did a good thing with that one. So Nolan, keep going. You had u as tangent x. Then what did you do?
Oh, well, I found the derivative.
Yep. What's the derivative of tangent going to be?
It's going to be secant squared.
Secant squared x. So notice we picked tangent because we have to take the derivative. And he was discussing that the next thing he would do is solve for dx. So he would multiply by dx on both sides, and he would divide by secant squared. So du over secant squared x is going to be equal to dx. When he plugs that back in a second, the secant squareds are going to disappear, which is going to make this problem a lot easier. There's one other thing we have to deal with, though. These bounds over here, this 0 and that pi over 4, were supposed to be plugged into x values. It was set up to be plugged into x values, but here in a second, everything in my problem is going to have a u in it. And so when we do this, we also need to change our bounds. And this seems tough, but it makes this problem pretty straightforward. We need to change our upper bound. What is our current upper bound? It is currently pi over 4. We are going to rewrite that upper bound as a u upper bound. Or in other words, we are going to take that pi over 4 and we are going to plug it in to whatever we decided u was going to be. So think about unit circle. I'm at pi over 4. What is tangent? What is y over x going to be right here at pi over 4? Square root of 2 over 2 over square root of 2 over 2. It's 1. It's radical 2 over radical 2. That is 1. And so my new upper bound is just going to be the number 1. We're going to do the same thing with my lower bounds. So initially, my lower bound was 0. But I'm going to change that lower bound to be in terms of u. And so I'm going to take the number 0 and I'm going to plug it into u. I'm doing tangent at 0. What is tangent at 0 going to be? 0. It's y over x. It's 0 over 1. It's 0. So tangent at 0 is 0. So the lower bound didn't change. Upper bound did. Lower bound didn't. that can seem annoying, like it was extra steps, it's going to be a really easy problem here in about 10 seconds. Let's plug back in. So now we're going to do all of that substituting. My lower bound is 0, so I'm going to plug in 0. My upper bound is 1, so I'm going to plug in 1. Tangent of x, I'm not going to write tangent of x, I'm going to plug in u. So I'm going to say u times secant squared x. And I'm not going to say dx. I'm going to plug in what dx is. du over secant squared x. And so this is why Nolan picked tangent here. He's got a secant squared x on top. He's got one on bottom. And so if he did it right, they're going to cancel. Now I have the easiest integration problem ever. We are integrating from 0 to 1 u du. What's the integration of u? I'm increasing my exponent. So my new exponent is going to be 2. And I divide by my new exponent, so it's 1/2 u squared plus c. Not plus c. Why not plus c? I got bounds. It's a definite integral. So I want to integrate that thing from 0 to 1. I'm integrating that thing from 0 to 1. So now all I need to do, because I changed those bounds to be u bounds, now I can just plug those in. So I've got a constant of 1/2. I can pull that 1/2 out in front. It makes my life easier. I'm going to plug 1 into this guy. What's 1 squared? 1. I'm going to plug 0 into that guy. What's 0 squared? 1 minus 0 is 1 times 1/2. The answer to that guy is 1/2. Square what? 1 squared is 1. Okay. I didn't skip it. Would you like me to write that? Okay. I did it. It's 1. Seems a little bit more challenging. It's not. Again, we'll pick that up again on Monday, so I'm not.